In this video, we're going to talk about naming carboxylic acids in organic chemistry. So let's start with our first example, where we have a simple carboxylic acid. So how do we name this carboxylic acid? So first of all, we have to find the longest chain, which is right here and has 4 carbons. Now 4 carbons is associated with butane, but instead of butane, we're going to write butanoic acid. And you can capitalize the B if you want. For our second example, let's take a look at another carboxylic acid. But this time we have a double bond. So once again, as always, our first job is to find the longest chain. And we have 6 carbons, which is going to be called hexanoic acid. But hold on a minute, we have a double bond, right? The double bond is in between carbons 3 and 4, but we're going to pick 3 because it's the lower number. So we're going to say 3 dash, and then we have instead of writing hexane, we're going to write hexene, and then we're going to go oic acid. So this is 3-hexanoic acid. How do we name this one? So if you notice, we have a carboxylic acid and then we have a ketone. Now which one is prioritized? Is the ketone prioritized or the carboxylic acid? It's going to be the carboxylic acid. So because of that, you'd start counting in this direction to give the carboxylic acid the lowest number. And then this is going to become a substituent as opposed to be part of the parent name. Since we have 5 carbons, that's pentanoic acid. And then this substituent is called oxo, and it's on position 4. So it's going to be called 4-oxopentanoic acid. Let's look at our next example where we have so on the left side we have what's called an aldehyde, and on the right side we have what's called a carboxylic acid, as we know. Which one of these is prioritized? The one that is prioritized is going to be the carboxylic acid. So therefore we're going to count right to left to give the carboxylic acid the lower number. And it looks like we have once again 5 carbons, which is pentanoic acid. Now notice that we have an aldehyde, but it's really the same as a ketone when we want to write it as a substituent. In the ketone, this was called oxo, and in the aldehyde it's going to be the same thing, but this time it's on carbon 5. So it's going to be 5-oxopentanoic acid. Actually, let's redraw this. My bad. how would we name this carboxylic acid? So we have a lot of substituents, but the carboxylic acid is going to be prioritized over all of them. Now let's find the longest chain. And since carboxylic acid is going to be prioritized, we're going to name it number 1 to give it the lowest number. We have 6 carbons, which is hexanoic acid, but we have a lot of substituents to write. So on carbon number 2, we have what's called a methoxy. So we're going to put 2-methoxy. And this is an ether, by the way. Carbon number 3, we have 3-amino. Whenever you see NH2, it's going to be amino. And then for number 4, we're going to have 4-bromo because we have a little bromine atom. Number 5 is an alcohol. Again, alcohol, the carboxylic acid is going to be superior to the alcohol, so it's going to be a substituent, and it's going to be called 5-hydroxy. 5 because it's on carbon 5, and hydroxy is the name of the OH. So now in order to write these substituents behind the heptanoic acid or hexanoic acid, we have to alphabetize them. So the one that comes first in the alphabet is the amino because A comes first. So we're going to put 3-amino. Then we have the bromo, 4-bromo. And then we have the hydroxy. So 5-hydroxy. Then we have the 2-methoxy. And I'm going to just move this slightly here. So that's how you name this carboxylic acid. Moving on to our next example, let's take a look at a carboxylic acid that is part of a ringed structure. How do we name carboxylic acids that are parts of rings? So you can see that the ring, we have 5 carbons, which would be cyclopentane, but because it's a carboxylic acid, we're going to write cyclopentane carboxylic acid. And this first portion, the cyclopentane carboxylic, is one word. Then you put a space between that and the acid. Now go ahead and work on this next example. Feel free to pause the video and do it. So we have a cyclopentane, which would be written as actually let's just move it left. We have a cyclohexane. Cyclohexane, and it has the carboxylic acid, so it's going to be cyclohexane carboxylic acid. Now we have a chlorine and we have a methyl, and the names of these are going to be chloro and methyl. If we count this direction, the chlorine is going to have 2, and then the methyl is going to have 4. If we count this direction, the methyl is going to have 2, the chlorine is going to have 4. So which one do we prioritize? Since the numbers are always going to be the same, we want to prioritize the one that comes first in the alphabet. And in this case, the C comes before M in the alphabet, so we're going to prioritize the chlorine. So this is going to be carbon 1 because that's the carboxylic acid, and then we're going to count this way. So we have 3-chloro, 5-methyl cyclohexane carboxylic acid. Now let's say we have a benzene ring and we have a carboxylic acid attached to it. And whenever you see COOH, that's just the same thing as like a normal carboxylic acid. So don't be confused by that. So this is going to be called benzoic acid because we have benzene and we have a carboxylic acid. So if you combine those, you get benzoic acid. Now, what if we have a benzene ring like we did before, and we have an iodine, have an ether on it, and we also have a carboxylic acid group. How do we name this benzene? So we have a few substituents. We're going to start at the carboxylic acid because that one always has the highest priority. Then we're going to go this direction to give the iodine and the ether the lowest numbers possible. So the iodine is going to get 2, so it's going to be 2-iodo, and then the ether, this is actually called ethoxy because you have 2 carbons attached to the oxygen. If you had 1 carbon, it would be methoxy, but here we have ethoxy, and then a 3 comes before it because it's on position 3. The parent chain name is called benzoic acid, as we said before. And when we write our name out, the ethoxy is going to come first because E comes first in the alphabet before I. So 3-ethoxy 2-iodobenzoic acid. So now what if we have a structure that has 2 carboxylic acid groups on it? How do we name that kind of compound? So first, you always find the longest chain, which in this case is 3. And then 3 carbons is associated with propane. But instead of just writing propane, you're going to write propane dioic acid. So that's how you name it. And since the P comes first in the name, you can alphabetize it. So propane dioic acid, and you don't need to put 1, 2 because carboxylic acids is always going to be toward the end, on the end of a carbon chain, since it ends with an OH. So now that you know how to do that last example, let's work on this one. Let's say we have a ketone group here, and we have a hydroxyl group and a methyl group. How are we going to name this one? So first you count the longest chain, and in this situation, do we go from right to left or do we go from left to right? If we go from right to left, the ketone group is going to be prioritized, and if we go left to right, the hydroxyl group will be prioritized. the name for the ketone is oxo, and the name for the alcohol is hydroxy. Since H comes before O in the alphabet, we're going to prioritize the hydroxy, so we're going to go from left to right. And so that is going to be called pentane. Now, since we have two carboxylic acid groups, it's called pentane dioic acid. And then we have, for substituents, we have a 3-methyl, a 2-hydroxy, and a 4-oxo. Since H comes first in the alphabet, we're going to write 2-hydroxy, a 3-methyl, and a 4-oxo.